Okay, so now let's go through this other nice idea, and that's the idea of set operations. So we're trying to go through set operations. Set operations, what are they? We'll be having one of four types of things that will be done to sets, okay? To try and focus on a certain part of a set or whatever. So the first would be, here are the set operations. I'll just list them for you first. One would be complement. Two would be union. Three would be intersection, and four would be difference. So if you see these things, then you are dealing with a set operation. We are working on a set somehow. So we'll start with complement. For these set operations, what you'll be doing is you'll be now meeting the Venn diagrams more. Venn diagrams to help you see the picture, all right? So if we start with intersection, with complement, complement just means that you'll be having something which is not what you are looking at. And we use this symbol, a forward slanting slash, and we like to call it prime. So we can say A prime or A complement, or the complement of A. So it's A prime. What is A prime? It's the complement of A. And this just means not in A. You want the things that are not in A. You may see it like this, A complement, okay? It means the same thing. Not in A. It's a small c like that. So let's say I would be having a set. Here's what we like to use, Venn diagrams. So I have something like this. Okay, then we start by putting one set, which is our set A. Now, there's always one big set which we will call the universal set. It's called the universal set, and it has the symbol U. It's the only one that is a box. It represents everything that we can consider, everything we can consider. So let's say we have our universal set having the numbers 1 to 9, but A having only even numbers. So 2, 4, 6, and 8. So that means the numbers 1, 3, 5, 7, and 9 are outside. So if you're then asked, what is A complement? We'll shade that region. They want the region which is outside of A. Okay, this whole region is what we will call A complement. It's the region which is outside of A, and that would be 1, 3, 5, 7, and 9. This is the complement of A. It just means not in A. Is that okay? Now we'll go to the next one, which is going to be the second thing, which is union. Okay, union. And the symbol is a U-like. It's a U-like, but it doesn't have you don't put this bar that goes down. Okay, so it's just a U. Now, what does union mean? When we say union, we are saying we are uniting the two things. We are bringing them together. We are uniting them to make one big thing. So here is the idea. We need to see what a union B looks like. So we'll put a Venn diagram, and we should be also able to represent it using set builder notation. These next three operations, we want to see their Venn diagrams, and we want to see their set builder notations. So here we now have two sets, set A and B, which will be interlocked like this, A and B, and this will be our universal set. If they say they want A union B, they want everything which is in A and in B. So we'll shade this whole region. This is the region which they mean, which they want, okay? This is the A union B. You are putting something that is in A or in B or in both, okay? We are just looking at things that are either in A or in B or in both. So let's say that A is made up of the numbers 1, 3, 5, 7, 9, okay? And then B is made up of the numbers 1, 2, 3, 4, 5. So if we were to make the set A union B, okay? Let me first tell you what it would be like. In set builder notation, it would be, first we will choose our variable. We're going to use X or M, whatever. In this case, we can use X. So we can say it will be all values X such that X is an element of A or X is an element of B. So this is easy to come from this to that, because you need to know what the symbol union means in English. It is or. So we will say X is an element of A or X is an element of B. That's how we put the union in set builder notation. Okay? So how would we get it? We would now say here, so this, the region I've shaded is the A union B. Okay? So what we would say is, if we were to get A union B for the sets we've put here, A union B would be, we would put anything that is in either in A or in B or in both. Now it's for these numbers, these small numbers, it's going to be very easy for us, because I'll just start with smallest number, just going up and see if it is in A or in B or in both. I'll take 1. Is 1 in A or in B? Yes, it's in both, so we can take it. 2, is 2 in A or in B? Yes, 2 is in B, so we can take it. 3, is 3 in A or in B or in both? Yes, 3 is in both, so we can take it. 4, is 4 in A? Yes, it's in B. It's B. It's not in A, but it's in B, so we can take it, because it should be in A or in B or in both. So because it's in B, we can take it. 5, is 5 in A? Yes, yes, 5 is in A, so we can take it. 6, is 6 in A or in B? No, 6 is not in any of them. 7, is it in A or in B or in both? Yes, 7 is in A. 8, is it in A? No. Oh, no. Is it in B? No, so it's out. 9, is it in A? Yes, so we can take it. It doesn't need to be in both. If it's just in one, we can take. If it's in both, we can take. That is what union means, and you'd be done. Now, the third one, it would be intersection. So we would say here on the third one, or maybe let me do the third and the fourth in the next video. Bye for now.